Hello friends, today we'll be solving a question related to transformer, and the question is the max efficiency of a 100 kVA single phase transformer is 98% at unity PF and at 80% of the full load. Okay, if the leakage impedance of transformer is 5%, then the voltage regulation at half load and 0.8 PF lead is. Okay, so how to solve this kinds of question? So first let us see what is the efficiency. Efficiency is output power over output power plus I square R losses plus uh, iron losses. Okay, so we know that for transformer there will be uh, according to the loading there will be according to loading there will be changes in the efficiency. Okay, and the curve will go like this. It will peak at some point. Okay, it will peak at some point, and after that again the loading because of the loading, the efficiency will go down. So this he's talking about this point, okay, where the efficiency is maximum. Okay, and that happens at 0.8 of the load. Okay, 0.8 of the loading. Okay, means 80% of the loading is 0.8. Okay, so if you write the formula for efficiency is output power over output power plus I square R losses plus iron losses. But at maximum efficiency I square R losses, okay, they become equal to iron losses. Okay, so where now our formula gets modified and it becomes output power over output power plus 2 twice I square R losses. Okay, now we will plug in all the values and we'll try to get our I square R losses. Okay, so here 0.98 is equal to 0.8 into 100 into 1, because this 0.8 is the loading, 100 is the kVA, and 1 is the power factor. Okay, so this is the output power. Okay, so this is 80 divided by 80 plus twice I square R. Okay, so twice I square R losses, because both of them are same, so I can write it as twice I square R losses. Okay, so now from here if you calculate your I square R, okay, so you get your I square R losses. Okay, these are at 0.8 loading. Okay, loading, and this come out to be, if you calculate this, it comes out to be 0. 0.86, 0.816. Okay, 3 kilowatt. Okay, so this is what you get at 0.8 loading. Okay, so your I square R losses will depend on loading square. Okay, whatever is a loading, it will depend on the square of your loading. So when it is fully loaded, then your loading is 1, and so at full load losses will be equal to 1 square over 0.8 squared into 0.8163. Now if you calculate this, it comes out to be 1.2755 kilowatt. Okay, so this is what you will get at full load. Okay, if you load at full load, then this is what you get. Okay, 1.225. Now we have full load losses, so what we can do is we can calculate R per unit from here. Okay, R per unit will be full load I square R losses, okay, over kVA rating. Okay, so your full load losses are 1.2275, okay, 755 over, this is 100. Now if you calculate this, it comes out to be 0.01275 per unit. Okay, now you have your R per unit and you have your Z per unit. Okay, so R per unit, Z per unit percentage is 5. So R per unit, if you convert it into percentage, then it comes out to be 1.2755. Okay, so now you can calculate your impedance angle. Okay, how you can calculate your impedance angle? Because this is theta, this is your R per unit. Okay, and this is your X per unit, and this is your Z per unit. So we know X per unit, Z per unit, and R per unit. So what we can do is we can use cos inverse theta is equal to cos inverse 1.2755 over 5 and if you calculate this angle, it comes out to be 75.22 degrees. Okay, so this is what you get. Okay, now you have your theta, and we know that what is our phi. Phi is minus cos inverse, okay, 0.8. okay, or phi is equal to, if you calculate this comes out to be minus 36.86 degrees. Now why are we calculating theta and phi? Okay, we are calculating this to find the voltage regulation, which is to be found at half of the load and at 0.8 pf lead. Okay, so you have to be careful, it is lead not lag. Okay, that's why I used the minus sign here. Okay, why? Because in our expression of voltage regulation, it comes which is loading times your Z per unit cos theta minus phi. Okay, so this phi is for lagging. Okay, so if you want to do use the formula for leading, you have to have a extra minus sign. That's why I put a extra minus sign here. Now you know that loading is half. Okay, so we put here half, and Z per unit is 5%. Okay, so let's put 5% here into cos theta. Okay, now your theta is 75.22, so you put 75.22 here, minus of minus 36.86. okay, so this is what you get. Now if you solve this, then you get minus 0.939%. okay, so your voltage regulation percentage is 0.939%. okay, so this is how you can solve a question related to your voltage regulation, where the efficiency is also given to you. And be careful that whether it is at lead or lag, and what is the loading. Okay, according to the loading, your your voltage regulation may be different. Okay, so thanks for watching.